Blue-green deployments for ML models. Dual environment setup. Maintain two identical production environments, blue for current and green for new version. Traffic switching. Gradually shift traffic from blue to green environment while monitoring model performance. Instant rollback. Quickly switch back to blue environment if issues are detected with the new model. Like having two lanes on a highway, you can test the new lane while keeping traffic flowing on the old one, then switch everyone over safely. Cost optimization strategy for Cloud ML. Spot instances. Use spot or preemptible instances for training workloads that can handle interruptions. Resource right-sizing. Monitor actual usage and adjust instance types to match workload requirements. Scheduled scaling. Automatically scale down non-production environments during off hours. Like smart shopping, buy in bulk for regular needs, use sales for flexible tasks, and turn off lights when not needed. Now, let's look at the tip section. Monitor costs daily and set up billing alerts to avoid surprise charges. Model versioning and rollback strategies. Semantic versioning. Use major, minor patch versioning to track breaking changes, features, and bug fixes. Canary deployments. Test new model versions on small traffic percentages before full rollout. A/B testing framework. Compare model performance across versions with statistical significance testing. Like having different editions of a textbook, you can always go back to the previous edition if the new one has problems. Multi-cloud data residency and compliance. Data sovereignty. Ensure data stays within required geographic boundaries using region-specific cloud services. Encryption in transit and rest. Use strong encryption for data movement and storage across cloud providers. Audit trails. Maintain detailed logs of data access and processing for compliance reporting. Like international shipping, some packages can't cross certain borders, so you need local warehouses in each region. Disaster recovery plan for ML systems. Multi-region backup. Replicate models, data, and infrastructure across multiple geographic regions. Recovery time objectives. Define acceptable downtime and data loss limits for different ML services. Automated failover. Use health checks and automated switching to backup systems when primary fails. Like having emergency exits and backup generators. If something goes wrong, you have a plan to keep everything running safely. Security controls for ML pipelines. Zero trust architecture. Verify every request and user, even within the internal network. Secret management. Use secure vaults for API keys, database credentials, and model access tokens. Container security. Scan images for vulnerabilities and use minimal base images with only necessary components. Like a high-security building, multiple checkpoints, ID verification at every door, and cameras monitoring all activities. Optimizing GPU utilization for large model training. Mixed precision training. Use FP16 instead of FP32 to double training speed and reduce memory usage. Gradient accumulation. Simulate larger batch sizes by accumulating gradients across smaller batches. Multi-GPU strategies. Use data parallelism, model parallelism, or pipeline parallelism based on model size. Like turbocharging a race car, use lighter fuel, better aerodynamics, and optimize every component for maximum speed. Now, let's look at the code section. Serverless architecture for ML inference at scale. Function-based serving. Deploy lightweight models as serverless functions for automatic scaling and cost efficiency. Event-driven processing. Trigger ML inference based on events like file uploads or API calls. Cold start mitigation. Use provisioned concurrency and model caching to reduce startup latency. Like having magic helpers that appear instantly when needed and disappear when done. You only pay for the work they actually do. Monitoring and alerting for cloud ML services. Multi-layer monitoring. Track infrastructure metrics, model performance, and business KPIs simultaneously. Proactive alerting. Set up alerts for model drift, latency spikes, and accuracy degradation before users notice. Centralized dashboards. Create unified views of system health across all ML services and environments. Like mission control for space flights, monitoring everything critical and alerting the team before small problems become big disasters. Data transfer and bandwidth optimization. Data compression. Use efficient compression algorithms for data in transit and storage. CDN for models. Use content delivery networks to cache models closer to inference endpoints. Incremental sync. Only transfer changed data portions using delta synchronization techniques. Like smart delivery trucks, they take the fastest routes, carry only what's needed, and deliver updates instead of everything. Hybrid cloud strategy for ML with on-premises data. Data gravity considerations. Keep compute close to data. Train on-premises where data lives. Deploy to cloud for scale. Secure connectivity. Use VPN tunnels and private connections to ensure secure data flow between environments. Workload distribution. Use on-premises for sensitive data processing, cloud for model serving and scaling. Like having a home office connected to corporate headquarters, sensitive work stays at home, but you can access company resources as needed. Cost allocation and chargeback for ML resources. Resource tagging. Tag all ML resources with team, project, and cost center information for accurate tracking. Usage metering. Track compute hours, storage usage, and API calls per team for fair cost distribution. Budget controls. Set spending limits per team with alerts and automatic shutdowns to prevent overruns. Like splitting a restaurant bill fairly, everyone pays for what they ordered, with shared appetizers split evenly. Now, let's look at the tip section. Use automated tagging policies to ensure consistent cost tracking across all resources. Amazing work, tech adventurers! You've just completed an incredible journey through advanced MLOps concepts. Let's celebrate your key takeaways. Architecture first. Design for scale, security, and maintainability from day one. Automation everything, from training to deployment to monitoring. Reduce manual interventions. Monitor continuously. Track model performance, infrastructure health, and business metrics. Optimize costs. Use right-sized resources, spot instances, and smart scaling strategies. Security by design. Implement zero-trust architecture and comprehensive compliance controls. Remember, great MLOps is like conducting an orchestra. Every component must work in harmony. You're now equipped with the advanced MLOps knowledge that top tech companies are looking for. Keep practicing, keep learning, and most importantly, keep building amazing things. Your tech journey is just beginning, and the future is incredibly bright.